Here I am with a new video to solve three fairly simple questions 1, 2 and 3. Before going further into the video, pause this video and try to solve by yourself. Let's see whether you can solve it. So here comes our first question. If you know the basic rules of integration, then this will be a very easy question for you. So I'll put I equal to the question, okay? So I have I equal to integration with the limits from pi by 6 to pi by 3. Remember, I have a tan x over here. I can write tan x as sin x by cos x. So since there is a root, I can write it as root sin x by root cos x. So dx by, okay, I have, instead of dx I'll write it directly, okay, cos root of cos x dx by cos x plus root sin x. So I integration pi by 6 pi to pi by 3, I have root of cos. Inside the bracket I can write pi by 3 plus pi by 6 minus x. That's a very important rule in integration. Divided by root of cos x, the same thing, pi by 3 plus pi by 6 minus x plus root of sin pi by 3 plus pi by 6 minus x dx, okay? So I have I equal to integral pi by 6 to pi by 3. What is cos pi by 3 plus pi by 6? That's pi by 2. What is cos pi by 2 minus x? Root of sin x, right? Divided by root of sin x plus root of cos x. Now, since I have right now, previously I had I equal to integration or integral pi by 6 to pi by 3. I had root of cos x by root of cos x plus root of sin x. This is what we began with, right? The first step was this. Then towards the end I had I equal to integration. The previous step was pi by 6 to pi by 3. I had sin x by cos x plus root of sin x, right? So I have dx over here and dx over here too. So if I add these two equations, I get, here comes the crucial part, 2i integral pi by 6 to pi by 3. What do I have in the denominator? Both the denominator and the numerator turns out to be the same. Dx. I can cancel both 1. And then I can, what is 1 dx? X. And if I put the limits pi by 3 to pi by 6, I'll get 2i equal to pi by 3 minus pi by 6, which I get as pi by 6. But what is I? I is a question. I is pi by 12. 2i, bring it over here, and pi by 12. Tiny answer. Right? Yes. So here comes our second question. Integral 0 to pi by 4 sin x plus cos x dx divided by 9 plus 16 sin 2x. I again name it as I. So I equal to, I can write this as, right, the numerator to be the same, sin x plus cos x dx, but I make it change in the denominator. I write it as 9 plus 16 sin 2x. If you remember, sin 2x is equal to sin x 1 minus sin x minus cos x whole square. Why so? Because sin x minus cos x whole square, you have sin square x minus minus 2 sin x cos x plus cos square x. So 1 minus 2 sin x cos x. What is 2 sin x cos x? 1 minus 2 sin 2x. So if I put 1 minus over here and put this in bracket, I will get, what do I get? 2 sin 2x. So instead of that I can write 1 minus this thing. Okay. So I am writing this as 9 plus 16. 1 minus sin x minus cos x whole square. Okay. I have dx over here. Okay, sine. So I equal to 0 to pi by 4. And then I have sin x plus cos x dx. Okay, now here comes the tricky part. I open the bracket. Not the tricky part, the confusing part. You might think how all of a sudden I'm getting 25 minus 16, which I'll get over here. I'm opening the bracket, so I'll get 9 plus 16 minus 16 sin x minus cos x whole square. So I'll get, if I add it up, 25 minus 16 sin x minus cos x whole square. Isn't it? Okay. Now I can write it as what? Okay. So here what I take right now is, I'll take 4 sin x minus cos x to be t. Okay. So I'll get 4 cos x plus sin x dx equal to dt. So I just have to multiply and divide it by 4. Multiply by 4, divide it by 4. Isn't it? So finally, and as the limits to change, x is equal to 0, I will get t equal to minus 4. And when x is equal to pi by 4, I will get t equal to 0. So here I will get integral 1 by 4, I'll take it out. Minus 4 to 0. And I'll get dt by 25 minus t square. Right. So I equal to minus 4 to 0 dt by 5 square minus t square. So I have 1 by 4 integral minus 4 to 0 dt by 5 square minus t square. What is integral of a square minus t square? I'll have log, right? So 1 by 4 into 1 by 2a. A is 5 over here. 2, 5 into log 5 plus 2. A plus x. A is 5, x is t by 5 minus t. And I'm putting the limits. So I have 1 by 40. Limits when I put, I'll get log 1 minus log 1 by 9. And what is log 1 minus log 1 by 9? Log 9. Why so? I can take it like this, no? What? Log 1 by 9. So log 9. So 1 by 40 multiplied by log 9, which is again 2 log 3, because this is 3 square. So I take 2 outside, 2 log natural logarithm. Okay, 3 by 40, or much more simpler, natural logarithm 3 by 20. Mod, it doesn't mean it's supposed to be confusing. So how do you do with integrals with mod? It's easy. First step is you have to split the limits. Okay, you have the limits over here, you have to split it. What do you mean by splitting? I'll show you. So from 0 to 2 by 5, 2 pi, I have between 0 and 2 pi, I have pi by 2, 3 pi by 2, and then comes 2 pi, right? So first I'll write 0 to 2 pi, okay, mod cos x dx is equal to, here comes 0 to pi by 2 cos x dx plus pi by 2 to 3 pi by 2 mod cos x dx plus 3 pi by 2 to 2 pi mod cos x dx. So now we need to find out in which of these intervals are cos positive and negative. So between 0 to 2 pi we have found out that cos x is positive. Sorry, not 0 to 2 pi, I meant 0 to pi by 2. Between 0 to pi by 2 we know cos x is positive, right? Because it doesn't oscillate over there. Between 0 to pi by 2 you have what all values? It's between 1 and 0, no? Then you have pi by 2 to 3 pi by 2, obviously, which is negative. So cos x is negative over there, and between 3 pi by 2 and 2 pi it's again positive. So the positive and the negative sign oscillates along with the intervals. We have discovered that over here right now. So this is positive, so I can remove the mod, and I can write cos x dx plus pi by 2, 3 pi by 2. This is minus cos x dx plus 3 pi by 2, 2 pi, which is again cos x dx. Okay. Now this is very easy. You know the integral of cos x sin x, 0 to pi by 2 intervals. Okay. Minus sin x. Yeah. Again, put the intervals. There again, sin x, put the intervals. 3 pi by 2, 2 pi. When I substitute with the intervals, I mean limits, sorry. Limits, I have been saying intervals, right? Limits. Whatever. 0 to pi by 2, 1 plus 2 plus 1 I get, which is obviously 4. So here comes the answer. So this is how you do with integration which has mod. Okay. Thank you. Hope you all enjoyed.